In the last module, I mentioned Path MTU Discovery, or PMTUD, and earlier in this module, I referenced the relationship between the TCP maximum segment size and the maximum transmission unit, or MTU. The TCP segment size is determined by the MTU minus the TCP and IP headers, so any change in the MTU anywhere along the path between two TCP hosts can influence how TCP performs. Before we can understand Path MTU Discovery, we need to understand exactly what the MTU is. MTU, or Maximum Transmission Unit, is a broad term, but in the context of Ethernet networks, it refers to the maximum payload or data that can be carried in a single Ethernet frame. The default MTU for Ethernet is 1500 bytes. This is the payload and does not include the Ethernet header itself. However, MTU sizes on Ethernet networks can be adjusted. R1 is connected to R2 and has an MTU of 1500 bytes. R2 and R3 are connected but have an MTU of 1280 bytes. Now suppose R1 wants to send a packet to R3 that is 1500 bytes in length. The packet goes from R1 to R2, no problem, but once it hits R2, R2 realizes that the packet is too big to be sent to R3 in a single frame because the MTU is smaller, only 1280 bytes. The smallest MTU along the path between R1 and R3 is therefore 1280 bytes. So that is the path MTU. So what happens? Well, if the packet in question here is an IPv4 packet, R2 will simply fragment the packet, split it up, and send it in two Ethernet frames to R3. No problem, right? Well, there are two potential issues with this configuration. The first issue is that the transit router, R2, now has to do extra work in fragmenting this packet. The second problem shows up if the packet being sent is IPv6. IPv6 packets are not fragmented in transit. If R2 receives an IPv6 packet that's too big, it will send back an ICMP v6 too big message. This is ICMP v6 type 2, telling the sender, in this case R1, to fragment the packet in order to fit the lower MTU size of 1280 bytes. R1 then fragments the packet to fit into the path MTU and resends it. Then R2 sends it along to R3. Now R1 learned the path MTU essentially by trial and error. By the way, this works similarly with IPv4. The only difference is that when Path MTU Discovery is enabled, the sender will set the Don't Fragment, or DF bit, which will tell the transit routers not to fragment the packet if it's too large. Instead, the transit routers will send an ICMP v4 destination unreachable fragmentation needed message back to the source. This message, just like the ICMP v6 message used with IPv6, tells the sender which MTU to use.